Welcome to EDU World Space.
This multi-part question starts by asking us if a complex absorbs light at 610 nanometers, what color would you expect that complex to be? So if you have something that absorbs at 610, that means it absorbs orange light. And therefore, the complex based on the color wheel, the color would be, let's see, color would be blue. Part B asks us what the energy in joules of a photon with a wavelength of light with 610 nanometers would be. And for that, we need to know the equation for energy, which is E equals hc over lambda. And there's a couple of different versions of this equation where E equals energy, and this correlates energy to wavelength, or lambda, where h is Planck's constant of 6.626 times 10 to the minus 34 joules second, and c is the speed of light, which is 3.00 times 10 to the 8 meters per second. And so we can calculate energy by putting in these values, 6.626 times 10 to the minus 34, and that is joule second, in parentheses, times the speed of light, which is 3.00 times 10 to the 8th, and that's meters per second. And with that, our seconds cancel here, line up, over our wavelength, which is 610 nanometers, which I'll convert to meters by doing times 10 to the minus 9 meters. With that, our meters cancel, and so we're just left with joules. And if we calculate that out, we get 3.253 times 10 to the minus 19, and our units there are joules per photon. Part C then asks us to determine the energy in kilojoules per mole. And so for that, for part C, we take this value, so the 3.253 times 10 to the minus 19 joules per photon, and we multiply it first to get kilojoules, where 1 kilojoule is 1,000 joules. We multiply that by Avogadro's number, which will get us to per mole. So that is 6.022 times 10 to the 23rd moles. Actually, photons per mole. And so moles per photon, sorry. And then we do that math, and we will get our value of 195.9 kilojoules per mole.